Hello. In this video, we're going to be finding the distance between and the midpoint between two complex numbers. So in number one, we have the complex numbers -4 minus 6i and -8 plus 3i. So before we begin, I just want to kind of get a quick visual of what this looks like here. So I'm going to draw myself just some coordinate axes here. There's the x. Okay, so the first number, -4 minus 6i, would be roughly here. So that's -4 minus 6i. And then -8 plus 3i is going to be over here somewhere. So let's first find the distance between them. So if I wanted to find the distance between these two numbers, well, basically we need to figure out how much did we go up and how much did we go over. So the amount that we went up, we started at a value of -6i. We went up to 3i, so we went up 9 units. While we went to the left from -4 over to -8, we went left -4 units. So the distance between them is going to be calculated by doing the square root of 9 squared plus -4 squared. So to calculate this, 9 squared is 81, -4 squared is 16. If we add 81 and 16, we're at 97. So the distance between these two numbers is the square root of 97 units. Now midpoint. Midpoint is the point exactly between them. So we need the number exactly between -6i and +3i. We need the number exactly between -4 and -8 on the real portion of this. So we had to go up 9 to get from -6 to +3. So instead, we can go up 4.5, half of 9 from 6. So from -6, if we went up 4.5, roughly there. The amount over, we went from -4 over to -8, so we'd have to go over 2 instead of 4. And so the point that corresponds to this is right here, exactly between them. Well, so 2 to the left from -4 puts me at -6. 4.5 up from -6i is -1.5i. So our midpoint is -6 minus 1.5i. Now we can do these going forward without having to draw the picture. We kind of have an idea of what's going to happen here. So in number 2, when I do the distance, so I'm going to start with the big square root, but I need to find the change from -5 over to -12. So I just do the subtraction, or the difference between the the real components squared, plus then the change between the imaginary components, 7 minus 2, quantity squared. So this works a lot like the Pythagorean theorem, the distance formula, and so on. -5 minus -12 gets me 7. 7 squared is 49. Plus 7 minus 2 is 5. 5 squared is 25. If we add 49 and 25, then I get the square root of 74. So that's the distance between those two. If I want to do the midpoint, if you remember what we basically do, we're just going to add these things up and divide by 2. That's the basic midpoint formula that we've done in the past. So I can literally just take -5 plus 7i, add to -12 plus 2i, and divide by 2, right? When we want to find the midpoint, I'm just doing the average of the two things. So we end up with -17 plus 9i divided by 2, so we get 17 halves plus 9 halves I. And that's the midpoint for this. All right, so let's do number 3 then. Just to kind of complete this, I want the distance between 11 and 9, which is 2 squared. The distance between negative 3 and negative I, which is also 2 squared. And so we get square root of 4 plus 4, which is 8. And the square root of 8 simplifies into 2 square root of 2. If I'm doing the midpoint, again, we add up our real components to get 20. We add up our imaginary components to get minus 4i. Divide that by 2. And then we simplify to get 10 minus 2i. Okay, that's how we find the distance and midpoint on the complex plane. For now, we are done.